Hello everyone, my name is Sanjay Kumar Khadanga and this is my customer project, customer segmentation on online retail store, and those are my team member Vibhutibhushan Sahu and Balram Panigre. So let's start our project. So first is our content. In this content, we discuss about the business understanding and data summary, some feature analysis and exploratory data analysis and data pre-processing, and some implementing some algorithms and some challenges, and lastly is conclusions. And if I talk about the business understanding of our problem, then the customer segmentation is the practice of dividing a company's customers into groups that reflect similarity among customers in each group. The goal of segmenting customers is to decide how to relate to customers in each segment in order to maximize the value of each customer to the business. Customer segmentation has the potential to allow marketers to address each customer in a most effective way using the large amount of data available on customers and potentially customers. A customer segmentation analysis allows marketers to identify the discrete groups of customers with a high degree of accuracy based on demographic, behavior, and other indicators. Given the dataset, the objective is to build a clustering model that would perform customer segmentation. Next is our data summary. This table consists of top five rows of the dataset, and here the total row are 5,41,909 rows are present, and there are total 8 columns, that is 8 variables present in our dataset. This transitional dataset with transaction occurring between 1st December 2010 and 9 December 2011 for a UK-based online retailer store. Many customers of the company are a wholesalers. Next is our feature summary. In feature summary, the content of the data had features such as invoice number. Invoice number is a nominal dataset. A 6-digit integral number uniquely assigned to each transaction. If this code starts with letter C, it indicates a cancellation. Next, stock code, product item code. This is a nominal dataset. A 5-digit integral number uniquely assigned to each distinct product. Description. It's basically the product name. It's a nominal data type. Next is quantity. The quantities of each product item per transaction. It's a numeric data type. And next is invoice data. Invoice date. Invoice date and time numeric. The date and time where each transaction was generated. Next is unit price. Unit price is the numeric data type, and it's the product price per unit in sterling. Next is customer ID. The customer number, it's a nominal data type, a 5-digit integral number uniquely assigned to each customer. Next is a country. Basically the country name, it's a nominal data type, and the name of the country where each customer resides. Next is our first insight from our dataset. First, this is the dataset from the UK. In our data set, there are 5,41,909 rows and 8 columns are present. 4 categorical features are present, that are invoice number, stock code, and description, and last is country. And next is there are missing value present and some duplicate value also present. Missing value present in description and customer ID. So we remove the rows, remove the null values and the duplicate values from this column, that is description and customer ID. There are some outliers also present in our data set. Some outliers are present in quantity and unit price column. We remove the outliers and some treatment also. We remove the cancel orders from the invoice number, and add new feature from date time column such as months, days, and columns and hours. Added a total amount, that is unit price into the quantity of the product, and convert the data type, various data types. Next is the analysis of customer ID. Here you can see that in the right side of the column, this is the bar plot, we can see that there are 4,339 unique customer IDs present out of Its top 5 customer IDs are whose frequency, means the rate of purchasing is higher. The ID number 17841 was the most active customer from them. Next is the analysis of the country. Here the data set represent the top 5 countries based on the number of customers. UK, Germany, France were the top countries having more number of customers. Since data belonged to the UK based company, UK had the majority of customers obviously. Next is the analysis of description. It is the top 5 product name in the right side bar plot. Here you can see that white hanging heart tea light holder is the highest number of purchased product, and Regency cake stand 3 tier. Next is jumbo bag red retro spot. Next is assorted color bird ornament. Next is party bunting. So next analysis is the our in stock, the stock name. Here the top 5 stock name in the right side bar plot, and here you can say that the stock name are 851238 is the highest number of stock name, stock code name. Next analysis is the month-wise analysis. So in the above plot, you can see that the number of customers who purchase item in basically in the month of 9, 10, 11 and 12. It's basically the September, October, November and December column. So we can say that it could be the months with the highest sales in anticipation of Christmas. Due to the Christmas, the sales also higher. Next is the analysis of the day wise. So most of the customers have purchased the items in Thursday, Wednesday and Tuesday. It did not relate to the weekend based column, because basically the sales are highs in weekend days, but it's a based on wholesaler company, so it's did not reflect that in general and common things in our graph. Next is the analysis of average. It is also basically the same. Here the left side it shows the sales according to the particular hour, and the next we convert it to the morning, afternoon and evening time. So here you can say that clearly the largest sales are occurring in the afternoon time. It basically from 11 to 15, that means from 11 a.m. to 3 p.m. Working hours witnessing the highest sales could be attributed to fact that a large part of the data set is wholesaler data. It clearly shows that, because it did not reflect the common people's behavior, that is they love to shopping in the evening time. That's why. So next is our analysis of numerical variable. There are numerical variable largely present is quantity, the amount of product customer buy, and the unit price. And we create a new variable, that is the total amount, that basically the quantity into unit price. So here we can see that these plots are highly positively skewed plots, so we need to transport through a log transformation. Next is our RFM model. RFM model, basically we create a feature such as recency, frequency and monetary. It basically based on the customer loyalty, customer value programming. So here the recency is the freshness of the customer activity, be it purchases or visited. Example like time since last order or the last engaged with the product. Next is the frequency of the customer transaction or the visits. Example like total number of transactions or average time between transaction, engaged visits. Next is the monetary, the intention of customer to spend or purchasing power of customer. Example like total or average transaction value. Next is the recency analysis. In recency analysis, this is the right side, left side plot is the normal distributed this plot, and here we transferred to through a log transformation, and you can see that in right side plot it's a slightly normalized curve. And the next is our same is the frequency. Here we can also see that it's a positively skewed curve. That's why we convert it to through a log transformation, and we have having a bell-shaped normalized curve. Same also monetary also transfer through a log transformation when you get the best bell-shaped curve, normalized curve. And next we perform the k-means clustering to this to achieve the topmost cluster group. And for that, we for validation of the k-means clustering, we use the similarity score and elbow method on recency and monetary group. And here the topmost of in the left side corner, we the elbow method for optimal k, and here you can see that the optimal k value is 2 because the sudden decrease of the curve starts from the 2. And here the right side top corner we get the total table of the similarity score, and for the similarity score for n cluster, that is 2, similarity score is 0.42, and for 3 it's 0.34, and as soon, so we can say that for cluster 2, that is k value, we get the best result. And here is the customer segmentation between the recency and monetary group, and we can see that there is the clearly grouping of customers through recency and monetary clusters perfectly. So next is our similarity score and elbow method on frequency and monetary. And here also in elbow curve we see that the optimal k value is 2, and in similarity score we get the cluster number 2 and similarity score also 0.47. For cluster 3 its similarity score is 0.4, and below this is the customer segmentation scatter plot cluster chart. And here we can see that the customer also grouped by between perfectly grouped by between the two cluster, that is frequency and monetary. So next is the similarity analysis on recency, frequency, and monetary combinedly. And for n cluster, that is 2, the average similarity score is 0.39, and for n cluster, that is 3, the average similarity score is 0.30. So we get the similarity score on average of frequency, and monetary. That is, we can say that the number of customer, that is 2, is the best validation score for our k-means clustering. Next is to analysis through graph. Here we can see that in top left corner, this is the cluster similarity analysis for k-means clustering on sample data with n cluster 2. And here we can see that in the green graph there is some negative values are present, and in below the customer the number of cluster there where that is 3, we can see that the negative values in this cluster are high. That means they did not capture the perfect cluster group. That's why we did not consider the number of customer 3, and we go for the number of customer 2. And in also right side top corner, this is the perfect scatter chart and perfectly clustered data. Here we can see that there is 2 group, and the data are perfectly clustered with these 2 groups. And next is the elbow method and cluster chart for recency, frequency, and monetary. And in elbow method, you can see that for both of these, we get the k group k optimal k number is 2, because suddenly a decrease of the curve starts from here. And the in the right side plot, that is customer segmentation on based on recency, frequency, and monetary, we can see that the perfectly customers are perfectly grouped in these clusters. So next is our the RFM analysis. So here we see that in our column, that is customer ID, recency number, frequency number, and monetary value, and we generalize it to the R score, F score, and M score, and after that we combine them to a RFM group, and we add to get a single value. That's why we add these group numbers 441, that's we get 9, that is RFM scores, and we normalized this recency, frequency, and monetary number via log transformation. We get the recency log and frequency log, monetary log, and basics on this we create a clusters. So here we get the cluster, that is 10, this type of clusters, and here the the small RFM score, that means the customer is loyal to the online store, because the loyalty lies where the customer visit the store frequency and recency and the money they buy. So here we can see that in RFM score 3, the recency value is 2 and the frequency value is 182, means the time, the number of time he visited the store, that is 182, and recency means the last time he visited, that means he last time visited before 2 days, and after 2 days he again visited to the store, and the frequency value is 182, and he spent that almost monetary value, that is 4310. That's why he is the valuable customer to the company, to the online store, and that's why we get the score, that is 111, and we combine the number, that is we get 3, and 3 is the best optimal number for any customer, loyal customer. We target as them as a loyal customer and provide them some discount and some offer for to stick with them. And next is our the largest which are the worst performing customer, that is the 12 number customer, that is the RFM score is we when get the 12, and here we can see that the RFM group is 444 and the recency is the 204, that means he visited the stores before 200 days ago. So next is our the hierarchical clustering. Here we can the number of cluster will be the, this is the dendrogram, and the number of cluster will be the number of vertical lines which are being intersected by the line drawn using the threshold point 90, and the number of cluster we get, that is 2. And we perform the DB scan, that is density based spatial clustering of applications with noise, that DB scans to recency, frequency, and monetary. Here we can get the scatter plot of clusters, and we see that customers are well separated when we cluster them by recency, frequency, and monetary, and optimal number of cluster is equal to 3. Here in DB scan we get the optimal number of cluster, that is 3. And while doing this project we came across some challenges, that is this is a large data set to handle, because it's have 5 lakhs rows and needs too much of plot and graphs to analyze this while doing the EDA, and there is some non-values and missing values and duplicate values also present in description and customer ID. So that's why we perform some remove methods, and continuous runtime and RAM crush due to the large set. It takes too much time to perform this analysis, and to find the right number of K for clusters. These are the challenges. So we next step is our the challenge conclusion. So we, after doing so much of analysis, we came to some points of conclusion. That's throughout the analysis we went through the various steps to perform customer segmentation. We started with data wrangling, in which we tried to handle null values, duplicates, and perform feature modification. Next, we did some exploratory data analysis and tried to draw observation from the features we had in the dataset. Next, we formulated some quantitative factors such as recency, frequency, and monetary, known as the RFM model for each of the customers. We implemented k-means clustering algorithm on these features. We also performed similarity and elbow method analysis to determine the optimal number of customers, that is 2. We saw customers having high recency and low frequency and monetary value were part of one cluster, and customers having low recency and high frequency monetary value were part of another cluster. We saw higher values of frequency, monetary, and low values of recency in deciding one class, and low values of frequency, monetary, and high values of recency is the deciding other classes. So that's our conclusion. So that's it. Thank you for having patience with me till the end. Thank you very much.